Okay, Bismillahirrahmanirrahim. Assalamualaikum. Alright, good morning. So today we continue our lesson on topic 2 regarding computer system. Right, everyone can see my slide, right?
Yes, we can see.
Yes.
Okay, alright. So today we will cover on 4 topics. I mean that 4 subtopics. One is system concept, then number system and representation, and information coding, and last one logic gate and simple logic circuit. Alright. So at the end of this topic, students should be able to explain operation involve information process cycle. Alright, dalam komputer ni dia ada process cycle. Right, they have a process cycle. We call it as a information process cycle. Right, this information process cycle include input, process, output and storage. Alright, so korang akan belajar lah apakah itu input, apakah itu proses, apakah itu output dan apakah itu storage later on. Alright, next we move to definition of computer. Right, what is a computer? So computer actually is an electronic device that accept input, means that accept the data. Wait, ada je yang okay. Alright, and then process data, and last one produce output. Alright, or we call it as information. Ada 26 dalam ni. Sepatutnya 25 kan? Kenapa ada 26? Kenapa ada 26? Okay, alright, never mind, we continue. Okay. Alright, next is what is computer system. Alright, actually computer system is a working computer. Alright, that include operating system, software and hardware which is necessary to make the computer function. So kita faham, so we understand that computer system must have operating system, software and hardware. So actually what is a operating system that you know?
Android, iOS.
Yes, Android, iOS, something like that. Alright, so what is software?
Software ni macam application dia.
Yes, application. Alright, so software ni adalah something yang kita boleh lihat tapi kita tak boleh touch. Okay, so hardware is something we can touch and feel and see. Right, that is hardware. Alright, so actually software actually operating system operating system is a part of the software. Alright, software we have 2 type of software. One application software and another one is system software. So operating system actually in the part of the system software. Right, sepatutnya dalam topik 1 dia akan bincangkan lah software dengan hardware ni secara detail. Okay, tapi sebabkan topik 1 korang tak masuk sebab cuti kan, so nanti korang boleh tengok video tu. Alright. Okay, so this is a component of computer system. We have hardware and software. Hardware, example of hardware is a CPU, and then input device, output device and storage device. Alright, so CPU tu apa sebenarnya? What is it? What is CPU? No, that one. What is CPU actually? Okay, macam normal user, dia orang tahu CPU tu adalah yang besar gerabak tu kan, yang apa? Yang dekat cyber cafe ada besar gerabak, dalam box ada motherboard, whatever semua tu kan. Betul tak?
Yes.
Tapi sebenarnya actually CPU is the brain of the computer itself.
Oh.
So sometimes we call it as a processor.
Oh, processor.
So that is a CPU. Right, the brain of the computers. Right, inside the CPU they have two types processing. One is ALU and another one is CU, control unit, and arithmetic logic unit. Alright, next we have software. As I said before, we have system software and application software. Alright, system software macam saya sebut tadi, kita ada operating system. Right, so we have so many operating system right now. See, we have Windows, we have iMacs, okay, we have Linux, we have Unix. So, and then we have inside the system software we have another type of software, we call it as utilities, right? So dalam sistem software dia terbagi juga pada dua, satu operating system, satu lagi utility software. Utility software ni macam bila kita you ada defragmental system, then we have system backup dan sebagainya lah. Alright. Tahu tak defragmental system tu? ScanDisk, tahu tak ScanDisk? Tak tahu. Tak apalah, nanti macam mana cakap. Alright, okay, kalau kita punya komputer tu ada error kan, bila kita on dia error, dia keluar blue screen, betul tak? Kalau kita error dia akan keluar blue screen, dan bila kita kat blue screen tu, komputer automatically akan buat scan disk. So maknanya dia akan scan balik susunan file-file di dalam storage supaya dia boleh baca balik dekat mana ada error. So itulah sistem utilities sebenarnya. Tapi rasanya sekarang susah, jarang kan, sangat jarang lah nak jumpa blue screen tu, betul tak? Am I right?
Good.
Okay, good. Alright, next is application software. Alright, so application software ni macam korang tahulah, ada banyak. So one of that is productivity software. So productivity software macam Microsoft Office lah. So kita ada Word, kita ada spreadsheet, kita ada presentation, kita ada apa lagi selain tu? Excel, yes. And then kita ada image editing, kita ada video editing, audio editing, then and much more lah. Game pun termasuk dalam application software. Alright. Okay, back we move to hardware. Okay, so CPU, alright. We call it as a CPU, or the full name is Central Processing Unit. Alright, as I said, it's also known as the brain of the computers, right? Hardware component of computer that process and control the flow of information. Right, this CPU interpret and carries out the basic instruction that operate a computer. Right, there are two components, as I said before. Alright, in the brain there are two components. One we call it as control unit, another one we call it as arithmetic or logical unit. Okay, kenapa dia ada control unit dengan arithmetic unit? Control unit ni untuk apa sebenarnya? Siapa tahu control unit untuk apa?
Tahu.
Control unit ni macam bilangan lah, macam bilangan kan, berapa bilangan dia proses, berapa hari data, bilangan data yang dia proses tu dia akan count dekat situ. Alright, bilangan data yang dia proses untuk menjadikan information tu, dia akan count dekat control unit. So and then data-data yang diproses semua akan data-data yang untuk diproses akan diproses sebagai di dalam ALU. So kenapa data-data dalam ALU, arithmetic logic unit, kenapa kalau data kita masukkan alphabet, kenapa dia suruh ALU ni yang proses? Why computer use ALU to process data? Sebab dalam komputer ni, komputer hanya faham dua je. On dengan off. Okay. Dia ada dua je komputer faham, on dengan off. So on ni mewakili digit nombor 1, off ni akan mewakili digit kosong. Okay, so komputer hanya faham 1 dengan kosong je, dia tak faham lain. So bila you tekan, katakanlah you tekan huruf A dekat keyboard, so komputer ni akan tukar A ni kepada nombor digit yang dia boleh, yang unik lah, yang dia dah setkan. Okay, contohnya kalau A maybe 0001, macam tu lah. So dia akan proses dalam bentuk number, binary number, 0 dengan 1. Sebab itulah dia katakan, sebab tu dia dalam CPU ni dia ada only have ALU to process your information. Okay, faham?
Faham, sir.
Okay. Alright, next we go for input device. So this is a easy one. So you can name it what is the input device. So any hardware component that allow user to enter data or instruction into the computer. Example, keyboard, pointing device, mouse, scanner, touch screen. What else? What else? Example of input device. Joystick, right? Okay, joystick also can be as a input device. Right, and then we have pen input, okay, and then video input from camera and biometric input, right, and so on. Right, next we go for output device. Alright, output device is any hardware component that convey information to people. Example, monitor, printer, headphone, speaker. What else? Apa lagi yang boleh dikategorikan sebagai output device?
Hard disk.
Huh?
Hard disk.
Hard disk? The one is storage.
Oh.
Right, output device, benda yang keluar daripada komputer, yang boleh keluar daripada komputer. Apa lagi? Ada jawapan? Ada apa lagi? Contoh output device.
GPS.
GPS? No. GPS. Dekat sini dia bagi contoh. Display device such as monitor and projector, and then printer, audio. Okay. And then apa lagi yang boleh dijadikan sebagai output device?
PlayStation kira ke, sir?
Ha?
PlayStation.
PlayStation?
Yes.
PlayStation apa?
PSP.
PSP. Okay, so joystick tu input. Joystick tu. Tahu joystick? Tahu tak joystick?
Tahu.
Joystick tu input. Okay, segala benda yang keluar dekat monitor tu output. Okay, so ada lagi macam-macam lagi yang boleh jadikan output. Alright, so later on lah, nanti korang boleh define by your own self. Okay, next is system concept. Storage device. So ada kawan kamu kata hard drive dan sebagainya lah. So this is storage device, the hardware that records and retrieve item from storage media. Okay, so we have hard drive. Okay, hard drive we have there, example is hard disk and SSD. And then we have portable memory, right? Or sometimes we call it as a flash memory. So we have memory card and thumb drive. Then we have cloud storage, example Dropbox and Google Drive. And last one, optical disc. We have CD and DVD. Korang kan zaman korang ni ada lagi ke CD dengan DVD ni? Siapa yang tak tahu CD dengan DVD?
Tahu.
Tahu kan? Okay, back to information process cycle. Right, a sequence of operation which work together repeatedly in cycle. There are 4 stages in information cycle, process cycle. One is input, process, output, and storage. Okay, alright. On the input side, alright, the process of entering data into the computers, and then in the process side, computer transform data into information. And then there are 2 options, either saving data or program or information for future use, or right, computer send to show information to the people in usable format. Alright, so they have actually process cycle they only have 3. Alright, input, process, and output. Alright, sometimes storage also we call it as output. Actually sometimes, right? Sebab on the output side they have an option whether want to save or to show the information to you, right? So actually an option. Okay, so the normal information processing cycle is input, process, and output. Alright, so look at here how the ATM works, right? Okay, the process of withdrawing money from ATM. Okay, nampak tak? Boleh nampak tak?
Nampak.
Okay, so this is how the way you keluarkan duit daripada machine ATM, right? So first is you go to the ATM machine, and then what? And then masukkan card. Okay, and then dia akan proses, and then you boleh keluarkan duit. So ia juga include dia juga boleh ditafsirkan dalam IPO ya, seperti yang kita belajar tadi, information process cycle, input, process, and output. Alright, so siapa boleh terjemahkan process cycle untuk machine ATM ni? Boleh? Senang je kan? So input dia adalah daripada card. Okay, you masukkan card, itu dalam input lah. Card reader tu. Card reader adalah the card reader is input device. So they will read the information inside the card, and then the ATM machine will process. Right, that one is the process side, and then after that the money will come out. So that one from the output device. So you can see that the process withdrawing money from ATM, inputs, alright, the system read from the account information store in magnetic stripe. Okay, that one the card that you have. Okay, the inside the card they have a magnetic stripe at the back of the ATM debit card, and then the system accept the type of transaction, withdrawal, personal identification, PIN, and amount from user. So that one is the input side. Okay, satu card reader, and satu lagi adalah apa tu? The keyboard. Alright, either to enter the PIN number or amount of the money that you want to withdraw. Is it okay?
Okay.
So that one we call it as a process, input process, right? So in the process side, Okay, system. The process side means that inside the system lah, what the system will do. That's it, the ATM system do. Okay, first one is verify ATM card, and then verify PIN number, determine transaction type, determine account type, determine amount of to withdraw, calculate the balance, and determine the notes required. That one is all of the process side. Okay. Okay, next is output. Alright. The system provide paper receipt for transaction and system display a message. Okay. So on the output side, one is to print the receipt of transaction. Printer lah, means printer, right? So and then the next one is system display message. So after the print receipt, so the display also will display the balance of your account. Alright, and then last one is the storage. Alright, the system will record the transaction and update the balance. That one on the storage side. Okay, faham tak? Do you understand?
Yeah.
Yes.
Yes. Alright, so next we go for the next example. Alright, explain how it works. Right, there are 4 main steps in information process cycle. Explain what are the input process, output, and storage. When you are given information, 8 times 2 is equal to 16 to be processed using a window calculator. Okay, siapa boleh terangkan? Who can explain? Ada tak sesiapa volunteer? Any volunteer to explain this, how it can work? How do you want to relate with the 4 main step in information processing cycle? So input dia apa? Input.
Kita tekan nombor tu.
Okay, right. So bila kita tekan nombor dekat calculator tu, itulah input dia. So proses dia?
Nanti dia akan kira lah.
Alright, and then when our input katakanlah input dia 8 times 2, so the process side we will process 8 times 2. Okay, and then output
Output dia 16.
output dia dekat monitor tu lah kan. Okay, so output akan keluar dekat monitor 16 tu. So how about storage? How about storage?
Dia akan simpan 16 tu.
Jawapan kita tadi.
Dia akan simpan RAM.
Right.
RAM tu bila kita, sebab dia untuk temporary kan, so dia akan simpan dekat RAM. Alright. Okay, itu je. Alright, storage data functions. Okay. So input dia ialah 8 dengan 2 that we are using from keyboard, and then we will process using multiply, and then output the result of the system will display on the screen. Then storage, alright, will kept in memory for the future use. Alright, okay, how about this one? Touch and go, right? Lukman is travelling from Nilai to Bangi. When he reached the Bangi toll gate, Zulkifli tapped in his touch and go card on the card reader. There are 2 activities for each operation in information processing cycle involved during that touch and go transaction at Bangi toll gate. So macam mana dia berfungsi? First kali Lukman is travelling from Nilai to Bangi. When he reached at the Bangi toll gate, Zulkifli tapped his touch and go card, and on the card reader there are 2 activities for each operation in the information processing cycle involved during the touch and go transaction at Bangi toll. ada dua aktiviti yang berlaku di dalam at Bangi Tollgate. Okay, so how is work?
Dua aktiviti tu dia touch and go tu. Lepas tu satu lagi yang palang tu naik atas ni.
Palang tu naik atas tu. Okay, so input dia apa? Dia scan card tu kan. Bila dia touch card tu, so card reader tu akan scan card tu sebut. Alright. So the machine read data and balance. Okay. So next input is the machine will read data and read balance, also read exit toll gate. Okay, the machines verify, touch and go, and calculate the balance, calculate amount to be paid, and the machine calculate amount to be deduct amount paid. Alright, that one is on the process. Okay, and then display output dia, display balance. Okay, and then display error when the balance in touch and go not enough on the screen and produce beep sound. Right, that one is the output side. And last one, the storage. You store the date and times. Alright, the activity. The activity you exit the toll or you enter the toll, and the system will store history of transaction, means that the balance and all that, right? So that one is the on the storage side. Okay, faham tak? Mudah je kan?
Faham sir.
Okay, mudah kan? Okay, so kita dah habis IPO and S, iaitu input, process, output and storage. Any question on that process, information processing cycle? Ada tak soalan? Sebelum kita masuk numbering system. Right, next we go for numbering system, or in here we call it as number system and representation. Right, as I said before, computer only knows the on and off. Alright, ataupun 0 and 1. Alright, dia hanya mengenali dua nombor tu je, kosong atau satu, ataupun on, off. Itu je. Right, dia tak tahu pun huruf A ke, huruf B ke, huruf W ke, nombor 2, 3, 4, 5 semua dia tak tahu. So dia cuma recognize kosong dengan satu ataupun on and off. Right, so data representation in computer, the received data input is recognized using combination of binary digit. So nombor 0 dan 1 tu kita panggilkan dia, we call it as a binary digit. Okay, binary means that what? Binary apa? By apa? By makna dia apa?
Dua.
Dua. So sebab tu yang saya cakap tu dia ada dia cuma kenal 2 digit je. Okay, by 2 digit. Okay, so makna dia kosong dengan 1. Okay, so it represent off and on. Okay, off is 0, on is equal to 1. Macam saya cakap lah. So sebab apa dia dikenali, dia hanya kenal on and off, sebab komputer ni pun adalah barang elektronik ataupun barang-barang elektrik. So barang elektrik dia cuma tahu hanya dua perkara je, on and off, tu je. Okay, dia tak tahu benda lain. Alright, so the two ways to represent data in computer, we call it as a binary digit, bit or byte. Okay, ada dua cara untuk represent data in computer, sama ada menggunakan binary digit atau bits or byte. Okay, binary digit is kosong dengan 1 lah. So byte ni adalah kumpulan pada binary digit yang satu kumpulan yang terdiri dari binary 8, satu kumpulan yang apa? 8 bits yang dikumpulkan sekali, itu sekali dia dikenali sebagai byte. 8 nombor 01 yang terdiri daripada 01 tu ada 8 yang dikumpulkan sekali, itu dikenali sebagai byte. Okay? Alright, next is data representation on and off. Okay, inilah contoh dia on and off. Okay, you punya power on and off. Itu kalau dalam komputer kita kenali sebagai 1 dengan 0. 0 bermakna off, 1 bermakna on. Okay? Alright, next is bit or binary digit. Right, the smallest unit of data a computer can process, right? It represents electrical state on or off. Right, bit 1 is represent on, bit 0 represent off. Okay, so next is byte. Alright, 8 bits that are grouped together. As a group together, we call it as a unit. It provides enough different combination of O's and of 0 and 1 to represent 256 character. Right, represent the characters such as digit, a letter, a punctuation, and then marks or any symbol in computers. So 256 character tu adalah you punya keyboard tu. Betul tak? Betul ke tak?
Betul.
Betul ke? Cuba you kira keyboard you ada berapa digit? Ada berapa button? Keyboard ada berapa button? Senyap je. Dah kira belum?
82.
82? So kenapa dia ada 256?
Ada yang caps lock kena, ada yang kena shift.
Okay, betul. So 256 ni termasuk dengan huruf besar, huruf kecil. Huruf besar dengan huruf kecil tu adalah ada nombor unik dia yang represent. So dia tak sama. Okay, termasuklah tanda seruan. Okay, and then number 2, 3, 4, 5, 1, 2, 3, 4, 5 tu semua ada bit yang represent dia. Okay, unique, yang tak sama dengan yang lain. Okay, alright. So next, we go next. Alright, there are different between bit and byte. Okay, bit means that the smallest unit of data that computer can process. Byte means that 8 bit are groups together as a unit. So macam saya cakap adalah bit tu dia mewakili binary digit. So 0 and 1. So byte means that the group of 8 bit means that ada 8 nombor, 8 binary digit yang digrupkan bersama. Yang tu dikenali sebagai byte. So means that 1 byte is equal 8 bit. Alright? So faham tak? 1 byte is equal 8 bit. Itu calculation dia. 1 byte is equal 8 bit. Okay, next we go for another representation, number system and representation. Okay, we call it as hexadecimal. Tadi kita ada binary, kita ada bit, and then now kita ada hexadecimal. Selain daripada hexadecimal, nombor biasa tu kita panggil apa? Nombor biasa yang kita ada ni 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Ni kita panggil apa? Ni matematik ni, matematik. Cepatlah. Ada tak semua orang ni? Nombor biasa tu kita panggil apa?
Integer.
Kan. Kita ada binary, kita ada hexadecimal here, kita ada bit, kita ada byte. Tapi nombor biasa yang kita selalu guna 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 tu kita panggil sebagai apa?
Digit je kan?
Bukan. Yang tu kita panggil sebagai decimal kan? Decimal number. Alright? Decimal makna dia per 10. Okay? So dia sepatutnya korang dah tahu dah. Yang ni yang korang belajar dalam matematik kita panggil kuasa-kuasa tu apa? Yang tu korang dah belajar belum? Dah kan masa sekolah menengah kan?
Dah.
1 kuasa 2, 1 kuasa 10, 1 kuasa 8, dah kan?
Dah.
So decimal tu adalah nombor biasa lah, kuasa 10. So kuasa 10 tu means that nombor biasa lah. Alright, so here we learn hexadecimal. So hexadecimal ni makna dia berapa? Hexadecimal berapa? Kuasa berapa?
8.
Hex.
6.
Yes. Hexa 6 decimal 10. Makna dia 6.
10.
6 10 berapa? 6 10 berapa? 16. Okay. Alright, so number system, alright. So decimal is base 10, binary is base 2, hexadecimal is base 16. Yang saya cakap tadi tu. Okay. Base dia. Alright, so look at on the table there. Okay, nampak tak table ni? Okay, the comparison between decimal number, binary numbers and hexadecimal numbers. So we have here decimal 10. So dalam binary kita represent 10 adalah 10 10. So dalam hexadecimal A, capital A dia akan represent sebagai 10 dalam decimal. Okay, sama juga dengan contoh dia 7 dalam decimal. Okay, dalam binary dia represent 0111. So dalam hexadecimal dia represent 7. Okay, so another example, dalam decimal kita represent 3 macam biasa kan, 3 kan. Bila kita tekan huruf 3 ni, komputer akan tafsirkan ialah 0011. Itu adalah nombor 3. So dalam hexadecimal dia tetap juga dipanggil, dia tetap juga akan represent nombor 3. Okay. Okay, tengok look at on the table on the right side. I mean that on your right side. Okay, this is example of the table example of the decimal number, binary number. So on the 10 decimal, so you can get hexadecimal capital A, right? On 15 decimal you can get hexadecimal capital F. Okay, and so on. Itu korang kena hafal lah, kalau boleh hafal. Alright? Is it okay? Okay tak?
Okay, sir.
Dia akan bertambah susah bila korang ada macam apa? Operation on this numbers. Right, katakanlah 3 tambah 3 tapi buat dalam bentuk binary. Macam tu. So keluarkan berapa nilai dia. So yang tu akan menjadikan complicated sikit lepas ni. Okay? Alright, so next is ni kita dah buat dah common number system. Kita ada decimal, kita ada binary, kita ada hexadecimal.
Sir,
Yep.
kalau untuk binary tu kan, dia memang ambil 4 je.
Macam mana?
Kan binary tu ada 4 nombor kan. 0000. Dia memang ambil 4 je.
Tak, dia depend. It's depend.
Oh.
Depend, dia ada lagi banyak.
Okay.
dia depend kepada byte. Okay.
Thank you sir.
Okay, right. Next is ni apa benda ni? Benda yang sama. Number system, set number of. Okay, next. Okay, next we go for decimal number, right? Decimal number actually is familiar, the normal numbers that you use in everyday life. It consists of numbers from 0 to 9. Example 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5. That one is, we call it as a decimal number. Macam saya sebut tadi lah. Okay. Nombor biasa tu kita kenali sebagai decimal number. Okay, so decimal representation. So we have 615 base 10. So 615 represent the quantity of 615. So we can make it like this. Alright, so this is base. Okay, and then this is the numbers that we chunk. Okay, so it become like this. Okay, so we can represent like 5 times 10, 5 times 10 base 10 base 0, 5 times then 1 times 10 base 1, and 6 times 10 base 2. I mean, it's not base 2, power of 2. Okay, alright, so 5 times 10 power of 0, 1 times 10 power of 1, and 6 times 10 power of 2. So total 615. Okay, next we go for binary number system, right? This is a method represent number that has 2 as its base, use only digit 0 and 1. Okay, bits 0 and 1 are joined together from binary numbers. Example 1010 base of 2 or 1100 base of 2. Okay, look at here. 1010 base of 2 is what? Berapa nombor dia tadi? 1010. 1010 berapa nombor dia? 1010 10. 10, right? Okay. Okay, look at here. Okay, this is how we calculate, right? Or we change from decimal to binary, or from binary to decimal numbers, right? So now sekarang ni kita ada table ni, so korang tak payah calculate. So dekat sini kita tengok on decimal number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? So dia dah siap-siap dah calculate untuk korang. Okay, macam mana dia nak dapatkan nilai binary. So dekat sini kalau decimal number dia 1, so binary dia 0001. So kalau decimal dia 2, binary dia 0010. Then 0011, then 0100, 0101 dan sebagainya seterusnya. Alright, so nanti untuk pengiraan macam mana nak tukar daripada binary ke decimal or vice versa, so dia ada pengiraannya sendiri dan saya akan tunjukkan selepas ini. Alright, so next, hexadecimal number system. Alright, a methods of representing number that has 16 as its base, right, and use 16 symbol to represent values from A to 9 and from 0 to 9 and A to F. Okay, the advantage is it can represent binary value in more compact and readable form, and the conversion between binary and hexadecimal is very efficient. That one is the advantage why we need to use hexadecimal. So example here, 3A is 16 or 9B4 16. Okay, so sebab apa wujudnya hexadecimal ni sebenarnya? Sebabkan binary number ni dia ada limit dia. Okay, so bila dia terlebih pada limit, so dia akan jadi macam nak kata error tak error, tapi dia macam mengelirukan. Okay, komputer mungkin boleh baca, tapi kalau human macam kita tak boleh baca. Alright, katakanlah dia ada 8 bit kan, dia ada 8 nombor. Hasil tambahan 8 nombor dengan 8 nombor tu, so dia akan jadikan sometimes dia akan jadikan jawapan ni dalam 9 number atau 10 number. So sometimes komputer dalam 10 number yang digit angka 9 tu terkeluar daripada byte. So sometimes nombor ke-9 tu dia represent negatif ataupun positif. Sometimes dia adalah hasil daripada tambah dua nombor tu. So kalau bagi manusia dia agak terkeliru lah. So disebabkan itulah diwujudkan hexadecimal. Okay? Faham? Alright, look at here, hexadecimal representation. Okay, sama macam binary representation. So dia ada base, dia ada power of 0, 1 and 2. Okay, macam binary kita ada 2 power of 0, 2 power of 1, 2 power of 2, 2 power of 3. Okay, so dekat sini kita ada, okay, start dengan 10 dia dah jadi A, and start dengan dia sampai 15 jadi F, and then yang ke-16 dia akan jadi dekat sini, dekat pindah dekat power of 1. Okay, 16, 17, 18 sampai 27, sampai nombor 27 dia akan jadi B dan seterusnya. So dia ada pengiraan ni sendiri. Korang nak hafal pun boleh, tak nak hafal pun tak apa, nanti bila kira korang akan dapat juga. Okay, so okay, next we go for binary to decimal conversion. Right, macam mana kita nak convert, right, daripada binary number to decimal number. So example here, in binary number the column weight, in the binary number the column weight again from the right to left follow. Okay, okay, so kita tengok dekat sini macam mana kita nak convert binary to decimal. So dia bila nak convert binary to decimal, kita akan baca daripada kanan ke kiri. Okay, itu maksud dia. Alright, next, this is example. Convert binary number 10110 base of 2 to decimal number. So kita masukkan dalam table, okay, 10110. So kita start balik dengan 2 power of 0, 2 power of 1, 2 power of 2, 2 power of 3 and 2 power of 4. So at the end ni kita akan dapat 2 power of 4 times 1 sama dengan 16. 2 power of 3 times 0 sama dengan apa? 0. 2.2, 2 power of 2 times 1 it become 4. 2 power of 1 times 1 become 2. 2 power of 0, 1 times 0 become 0. So selepas itu kita campurkan semuanya. So kita akan dapat dia punya binary, dia punya decimal number. Okay tak? Boleh faham tak?
Boleh sir.
Okay, to convert from decimal number to binary number, alright? Convert 18 in binary number from forms, alright? So dekat sini kita ada binary, dia 18. So macam mana kita nak convert dia, kita ada decimal 18. So macam mana kita nak convert dia menjadi binary? Kenapa? Macam mana kita nak dapatkan binary dia? So kita buat 18, kita letak atas sekali. Alright, so 18 kita bagi dengan 2 jadi 9. So dia akan cari balance dia tak ada kan? So tak ada balance kan, betul tak? So tak ada balance, so balance dia jadi kosong. Alright, so and then next 9 bahagi 2 dapat 4 point berapa? 4.5 kan? So dia ada baki, betul tak?
Betul.
So 9 kalau bagi 2 dapat 4 kalau dah 9 bagi 2 dapat 4 kan? So point 5 baki dia kan? Betul tak? So 4 kali 2 adalah 8. So 8 tolak 9 baki berapa?
1.
So baki dia 1. Alright, so sama juga ni. 4 bagi 2, so tak ada baki, so jadi 2. So 2 bagi 2 dapat 1, tak ada baki juga. And then 1 bagi 2 dapat 1 bagi 2 iaitu 1 dapat kosong. Baki 1 bagi 2
Tak boleh.
kenapa tak boleh? So 1 dapat kosong, baki 1. So dekat sini kita tengok apabila dah habis sampai kosong, so dia akan baca daripada bawah ke atas. Macam ni. 1 0 0 0 1 0. Alright, so let's go for another example. Senang kan? So kita tengok another example. Ni slide. Okay. Alright. Okay, nampak slide Okay, next we go for information coding scheme. Alright, dekat sini dia ada scheme ASCII. Alright, ASCII 2 stand for American Standard Code for Information Interchange, ASCII. Right, and then beside of that dia ada scheme lain iaitu EBCDIC. Okay, means that a standard binary coded decimal interchange code. And last one, they have Unicode, uniform code capable of represent all world language. Alright, so this is the difference between coding scheme. Right, for ASCII only use 8-bit to represent a character. Right, it can represent 256 character and primarily used on the PC and server. For EBCDIC, also use 8-bit to represent a character and also represent 256 and primarily used on the mainframe and high-end server. Right, so last one is Unicode. Right, Unicode use 16 bits to represent a character and thus capable to represent 65,536 character. Right, it is implemented in several operating systems such as Windows, Mac OS and Linux. Unicode also used in the used in the PC and server. Alright, logics. Next we go for logic operator. Logic operation with any operation that manipulate boolean values. Right, example, boolean operation, an expression that return a boolean data type. Okay, we have basic logic operator and or not. And, logic or, and logic not. Okay, logic and is written true output when all the input are true. Okay, written false output when any all of input are false. Example, boolean expression y is equal a b, y is equal a times b, or y is equal a subset of. Is it subset, this symbol?
No.
No.
What is it?
Persilangan.
Intersection.
Huh? Intercept.
Intersect.
Intersect of b. Okay, so y equal to a and b. Alright. Okay, look at the table of the truth table. Here the table we call it as a truth table. Okay, so they have a and b. If true become true, true false become false, false false, false true become false, and false false become false. So this is the symbol of the logic and. Alright, a and b, there are two input a and b, and then output only one is equal to y. So you can represent of this logic gate into the truth table. So we count as 1100 and 1010. So become 1000. Kenapa kita gunakan 1100? Kenapa tak 1010? Boleh tak? Boleh tak?
Nanti result dia sama.
Ha?
Kita macam kalau A 1010, B 1010. Y dia sama ke A 1010.
Okay, so dia mesti suatu benda yang beza lah. Kalau kita mulakan 0011 pun boleh actually, tapi kita kena ada perbezaan antara dia punya apa input dekat B. Alright, tak semestinya kita start dengan 1100 ni. Kita boleh juga start 1010 ataupun 0011, and then dekat sini kita susun balik lah supaya dia tak sama. Okay, supaya dia tak sama dengan yang ada dalam ni. Okay, contoh dia macam ni 1111, 1 dengan 1 kan. So lepas ni dia tak ada lagi dah 1 dengan 1. Okay, mesti 1 dengan 0. So 0 dengan 1 and 0 dengan 0. Okay, so secara general je, AND logic ni adalah perkara yang hasil darab. Okay, you boleh darabkan macam A dengan B kan. So 1 times 1 equal to 1, 1 times 0 equals 0, 0 times 0, 0 times 1 equals 0, 0 times 0 equals 0. So N ni, untuk mendapatkan N ni adalah hasil darab, multiply. Okay? Okay tak?
Okay.
Okay, very good. Alright, next is we have OR logic gate. Alright, this OR logic gate return true output when any of the input are true. Return false output when all input are false. Example. Okay, y equal to a plus b and y equal to a. U is what? Union. Union of b. Okay. Alright, look at this is the logic gate of OR. Okay, yang tadi N dia lurus kat sini kan. So OR dia ada lengkung sikit. Alright, so A or B, they have two input A and B, and then another output is one. Only one is Y. So it will present on the truth table. We have 1100, we have 1010. So untuk mendapatkan OR ni adalah hasil tambah, right? Okay, macam hasil tambah. So 1 plus 1 is equal to 1, 1 plus 0 equal to 1, 0 plus 0, 0 plus 1 equal to 1, and 0 plus 0 equal to 0. Mudah kan? Sangat mudah, betul tak?
Betul.
Okay, alright. So next gate, logic gate is NOT. Right? NOT means that the change one logic input to the opposite output. Right? It return true value if the input is false. Return false value is if input is true. Right? Assume A is input of and Y is output. Logic gate of not logical. Okay, this is the logic gate of the not. Okay, selalunya dalam ni dia akan bagi satu input, satu output. Okay, ni yang dikatakan sebagai not. Sebenarnya kalau ada huruf ni yang kosong ni pun dia sebagai not. Alright. So dalam in the Boolean expression you can say that y is equal to ni tanda cacing ni. Tanda cacing ni dalam bahasa Inggeris apa? Nimda. Okay, and A and Y equal to not A. Okay, tanda seruan ni kita panggil not selalunya. Not A, and then Y equal to A prime. Okay, so the not true table, they have only two. Because Y2.
Not gate is only inversion. Dia macam balikkan je.
Tak,
Ada
kenapa?
satu kaki je.
Yes, sebab dia ada satu je. Sebab dia ada satu kaki je. Yang lain semua ada dua input, tapi untuk not dia ada satu input. Ni satu input dan satu output kan. So dia satu input je lah. Okay, 1 and 0. As I said, 1 and 0. And then untuk output dia akan berlawanan daripada input. So kalau input dia input dia on, so dia akan jadi off. Kalau input dia off, dia akan jadi on. Okay?
Okay.
Alright, so selain daripada tu, okay, beside of that, they have a combination of different logical operators such as NaN, NO, XOR and XNOR. Alright. Look at here, this is an example of NaN, alright, combination of AND and NOT gate. Right, produce true output when any of the input are false, produce false output when all input are true. Okay. This is example of NaN gate. Okay. NaN adalah combination from AND and not right. AND and not right. So dia sama ada, dia akan represent sama ada dalam bentuk macam ni, and not, ataupun and then this is, we call it as a not also. The bulat kecil ni. Not. Alright. So kita akan dapatkan truth table dia. Okay, kita akan dapat truth table. So macam mana kita nak buat truth table dia? So kita akan count truth table untuk not, and dulu. Untuk and dulu, 2 input. Untuk and, so akan dapat, okay, so dia dari 1 1 0 0 1 0 1 0 1 0 1 0. Okay, so A times B, so dia akan dapat lah kan. So akan dapat 1 0 0 0. So not bagi A times B adalah 0 and 1 1 1 1. Okay, itu adalah NaN gate. Okay, boleh? Boleh tak?
Boleh, sir.
Boleh sir.
Alright, good. Okay, next is no, combination of OR and NOT gate. Sama jugalah. Okay, bila kita dapat OR gate tu, then bila kita sambungkan dengan NOT, dia akan jadi terbalik daripada jawapan OR. Okay. So dia ini adalah macam mana kita represent logic gate tersebut. Okay, sama ada dalam bentuk macam ni ataupun kita letak kosong je kat belakang ni. So kalau kosong ni mewakili NOT. Okay. Alright, so ni macam saya cakap tadi, truth table dia. Okay, at the end dia kita akan terbalikkan, yang mana true akan jadi false, yang mana false akan jadi true. Sebab because of the NOT gate. Okay, so next we have XOR. Okay, OR gate, exclusive OR gate. Logical operations. XOR gate or logical operation means that return true if any input is differ. Return false if all inputs are if all its input are all the same. Okay, the Boolean expression equal to A XOR B. Okay, look at the truth table. Okay. Assume A and B are inputs and Y is output. Logical gate. This is a logical gate of XOR. There are the 2 input and 1 output. Okay, the truth table. How they do in the truth table? Okay, we have A and B, 2 input. Okay, 1 1 0 0. Okay, and then we have B 1 0 1 0. So A XOR B 1 1, so become 0, 1 0 become 1, 0 1 become 1, 0 0 become 0. Maksud dia apa? Dua benda yang sama dia akan jadi false. Dua benda yang berlainan dia akan jadi true. Okay, faham?
Faham, sir.
Okay, good. Seorang je yang faham
Faham sir.
Okay. Alright. Saja je bagi korang pening pagi ni. Okay, so next is XNOR. Macam sama je. Betul tak?
Baik sir.
Yelah, XNOR ni dia terbalikkan lah daripada yang dia dapat XOR tu. Kan? Kalau dua benda yang sama dia akan jadi true. Dua benda yang sama akan jadi true, dua benda beza akan jadi false.
False. Yeah.
Macam tadi tu Macam tadi dua benda yang macam mana?
Dua benda yang sama
Akan jadi false. So dia terbalik lah sebab no, bila ada no gate tu, bila ada not gate tu, dia akan jadi terbalik kan jawapan.
Oh.
Yup.
X no ni dia apa dan apa?
X no ni adalah eksklusif XOR tadi tu tambah dengan not gate. Ni yang dari ni XOR ni. So dia tambah not gate.
Oh.
So jadilah X no. Kan? XOR tu bila dapat XOR dan kita notkan balik. Not maknanya kita terbalikkan balik.
Maksudnya eksklusif or tambah not?
Yes. Alright.